By now you should have done some simple nets by cutting out some pieces of paper and making 3D shapes out of it. We're going to take that a step further now and actually relate these nets to some surface area. So you should remember that a net is a two-dimensional shape that can be folded into a three-dimensional object, which you would have done with the paper to make some cubes and some pyramids and some cylinders. Now we have this question down here that's saying Maria built the wooden cabinet below. She plans to use 2 coats of stain on the outside of the surfaces. This includes the bottom and the door. 1 liter of stain covers 80 square feet. Is 1 can enough to stain the cabinet? So this breaks it up in some pieces for us so we can find A, the surface area, and then see if the actual amount of paint or stain is enough. Now there is something that you should pick up whenever you read these questions right away. If I look at the dimensions of the cabinet, it's in inches. And then when they talk about the stain at the end, it's in square feet. So before we do a final calculation, we're going to have to do a conversion here, but we'll walk it through together. Now it says draw the net of this cabinet. Really, this is just a rectangular prism. This rectangular prism has 6 sides on it. There's this side right here, this side, the front, the back, and the top and bottom. That makes 6 sides altogether. So our final net, and we're just sketching this, our final net should also have 6 sides, but we're going to label the dimensions on it. So if I was to start with the top of it, here's the top of the cabinet. This would be 24 by 16. Then we have the long door, which is 48 inches long. Bear in mind that we're not making this to scale, we're just drawing a sketch. Then we have the bottom. If we were to fold that underneath, that would become the bottom. And again, this is 24 by 16. So I have 3 sides here. I need to have the other 3. So I can do the sides of this cabinet, which are still 48 long, but they're only 16 wide. So this covers the sides of the cabinets, the 16 by 48. So now if I look, if I was to fold this all together, I wouldn't have a back to it. So I need the back somewhere that would fold. The back's going to be the same size as that. So we need to attach it and have it the same size roughly. Here, this would be the back of the cabinet. So if I'm looking at it, we can clearly see that we have 6 sides of this cabinet. And here's all the dimensions on it. We will keep the dimensions in inches and work with the conversion at the end. Now it asks, what is the surface area of this cabinet? So again, we can go through and label everything we know in here of all these sides. All of these are 48, these long lengths. These are 16s. This guy here is the 24. And I think if we're looking at all of our rectangles, we should have all the dimensions of these things put on. So if we went through and labeled these, I'll go, this will be side 1, this will be side 2, because these are the same dimensions. So when we're finding the surface area, we talked about sides 1 and 2. Well, they're just 48 inches high, and they're 24 inches wide. That turns out to be 1,152 square inches, which is the front and the back of this cabinet. And then if I look at some other sides on here, like these narrow sides, here's side 3 and here's side 4, these are 16 by 48 rectangles. So on sides 3 and 4, this is 16 by 48. Simple calculation tells me that's 768 square inches. And I should include the square on the one above it, which means the other side is also 768 square inches. Now all I'm left with now are the top and bottom of the cabinet, which I'll just say these are sides 5 and 6. And these are 24 by 16 rectangles. So sides 5 and 6 are 24 by 16, which when we crunch that number out, that's 384 square inches. So 384 square inches is the bottom as well. Now the surface area of this whole shape, if we add up all of those sides, is 4,608 square inches. So now the question continues, and it's saying, now that I know it's 4,608 square inches, and the original question here circled in green says one can is going to cover 80 square feet, and she plans to put 2 coats on it, well, one can do the job. Now this is where we have to convert our square inches into square feet. Now one thing you should know from math in previous years is that 1 foot is the same thing as 12 inches. So if this is a 1 foot square, that's like saying there's 12 inches here and 12 inches here. This would be 1 square foot. The area of 1 square foot is 144 square inches. So there's 144 square inches in 1 square foot, which means if our cabinet was 4,608 square inches, and I divided that by 144 square inches, this will tell me how many square feet this cabinet actually is. This cabinet turns out to be, when we crunch those numbers, 32 square feet. So she needs to paint 32 square feet, but the question does say she wants to put 2 coats on. So we'd take that 32 square feet and say, well, I got to paint it twice. So times it by 2, which means she's actually painting 64 square feet. The question does say that 1 can would cover 80 square feet. Well, that's more than enough to cover here. So to answer this question, will 1 can be enough for 2 coats? We'd say yes. 1 can would work. So make sure you always answer the final question. The next question shows us a net of a cylinder. And we read the question saying we're talking about a water pollution control center, and it has some cylindrical tanks. It says bacteria cleans the water, and each one has a radius of 16.5 meters, and it's 8.6 meters high. And it says maintenance staff paint the tops and the sides of the tank. So they don't paint the bottom of these tanks, and that's important when we're talking about the surface area in this question. Now you'll need to add this measurement to your diagram, but the rest of the information is provided. They're saying that the radius of each of the top and bottom is 16.5 meters. So the radius is 16.5, 16.5. And it says once this thing stands up, it's 8.6 meters tall. So this distance is 8.6. So to give you somewhat of a visual of what this thing's actually looking like, it's looking like here with a very big top compared to its height. Now, all it's saying is that the people that paint these only paint the sides and they only paint the top. So they don't need to paint the bottom. So when we discuss this question, we don't have to consider one of those circles. Now, the shape only consists of 2 parts then. We have the top, which is a circle. And the top, the area of a circle, would be pi r squared. Then we have all the stuff that wraps around these tanks, so the side, and the side is just one long rectangle, and the area of a rectangle is length times width. So if we consider the top, the area is pi times the radius, which is 16.5 squared. So you can either go pi times 16.5 and use the square button, or pi times 16.5 times 16.5. So in your calculator, you can say pi times 16.5. I'll use the squared button. And I'm going to say that's 855.3 square meters. So 855.3 square meters. Now the rectangle is just 103.6 meters long, and it's 8.6 meters tall. These are fairly large containers. And if I find the area of this, it rounds to approximately 891 square meters. So this is the top and the bottom. Remember, we don't have to paint, or sorry, this is the top and the sides. We don't need to paint the bottom of this tank. It's sitting on the ground. So now to find the area that needs to be painted, which is the surface area in this question, we take the 855.3, we add it to the 891. So the surface area that needs to be painted in this question to the nearest square meter, the question says, is 1,746 square meters. That's a lot of paint.